So today we're going to talk about a second form of a linear equation, and it's called standard form. I have an example of standard form in the middle of this slide. We're going to write linear functions in standard form, and then we're going to use standard form to graph and solve real-world problems. Let's start right off talking about what is this. So the slope-intercept form, y equals mx plus b, is just one form of a linear equation. Standard form is another way that we can write it. So basically, if we take a look at this one, this time the y isn't by itself. Notice the x term and the y term share the same side, and the constant is by itself. The other requirements of standard form, you really got to pay attention to this, is that the a, the b, and the c all have to be integers. That means no fractions, no decimals. And a and b can't both be 0. Otherwise, we actually wouldn't end up with a variable in there. This form helps you make really quick graphs using the x and y intercepts. That's kind of where we're going to start, just remembering, about those. But basically what I want you to think of is that the slope-intercept form, y equals mx plus b, and the standard form, ax plus by equals c, are just two different names for the same thing. They're just two different ways to write the same line. So if you look at Mrs. Woodruff, my name could be standard form, Mrs. Woodruff. But I'm also called Mrs. W, and that could be y equals mx plus b. So it's still me, but it's just two different ways to write my name. So don't forget that the y-intercept is the y-coordinate of the point where the line crosses the y-axis, and the x-intercept is the x-coordinate of the point where the line crosses the x-axis. So just so we kind of get those thoughts in our mind, what we're going to do is just look at these four lines, and we're going to write their x and their y intercepts. Okay, so let's start and see how you did. The x-intercept of the blue line, line number 1, it crosses the x-axis at 7, right there. And the y-intercept would be -6. Line 2, the x-intercept crosses at +1 right here, and it crosses the y-axis at +3. When we look at this horizontal line, it has a y-intercept of 8, but it never crosses the x-intercept, so it does not have one. Make sure you don't put 0 here, because 0 would be a number that it's crossing. And for the yellow line, it's the opposite. That vertical line has an x-intercept of -8, but it will not cross the y-axis, so it does not intercept the y-axis, so it has none. So those are what x and y intercepts are. If you knew the x and the y intercepts, if I said, hey, there is a line with an x-intercept of 1 and a y-intercept of 3, you could just come onto the coordinate plane, go to the x-axis, put a point where the 1 is, and put a point on the y-axis where the 3 is, and join them, and you've got the line. So just think about that. If you had the x and y intercepts, you can graph the line very quickly. So the first thing I want you to notice, if you look at the actual y-axis, I've picked 4 points off, and I have written their coordinates. What do you notice is the same on every single point? Did you notice that the x-coordinate is 0? So believe it or not, whenever there is a point where x equals 0, then that would fall on the y-axis. Now let's take a look at the x-axis. I've again picked 4 points on the x-axis, and what do you notice here? Did you notice that every y-coordinate is 0? So if you have a point with a y equaling 0, that would be the x-intercept. So taking that idea, I'm going to give you an equation that's in standard form. Remember, for the x-intercept, for it to cross the x-axis, the y has to equal 0. And for it to cross the y-axis, the x has to equal 0. Kind of an opposite thought there. So to find the x-intercept, you substitute 0 in for y and solve for x. So for the x-intercept, you're going to put a 0 in for y and solve for x. 4 times 0 is 0. You got a one-step equation, divide both sides by 3, and there would be my x-intercept. For the y-intercept, you got to let x equal 0. 3 times 0 is 0. One-step equation, divide both sides by 4, and your y equals 2. So for this line, the x-intercept is 8/3, and the y-intercept is 2. Oh, by the way, we would divide this and get 2 2/3, so we kind of knew where the point was. So can I show you an easier way to do this? Remember that for the x-intercept, you put 0 in for y, and basically that term disappears because it's times 0. So you can almost go up in this original equation, and for the x-intercept, you just kind of cover that over. And do you see the one-step equation here? You divide both sides by 3, and you get 8/3. Now let's say you're looking for the y-intercept. This time the x term is going to disappear when you put the 0 in. So you can kind of just, cover that up and divide by 4, and you get the y-intercept. Now once you have these, plot 8/3 on the x-axis, plot 2 on the y-axis, connect them, and you've got the line. So remember that we have the x and y-intercepts from this standard form line. So now I'm just going to take, let me go with the red, 8/3 would be 2 2/3. So 1, 2, and about 2/3 of the way. So then about there look good. And then the y-intercept would be 2. Then I would take out my ruler and I would draw a line connecting those. And that would be the equation of the line 3x plus 4y equals 8. Let's do another one here. So here is one for you to do. Find the x and y intercepts, and then we're going to graph it. So again, you're going to need some coordinate graph paper, your notes page, whatever, so that you're working with me as we go through these. Okay, so what is the x-intercept? X-intercept means that you're going to let y equal 0. I mean, this is the math. So this term is basically going to disappear, right? So this disappears. You divide both sides by -3, and you'll get the x-intercept of -4. You're going to go on the x-axis and put a point at -4, and you're starting your line. Now, if I want to know what the y-intercept is, I have to put a 0 in for x. And basically, this one's easy to show with the screen. That term is going to disappear, and this is the one-step equation you're going to solve. Divide both sides by 4, you'll get a y-intercept of 3. So let me show you that math. So this term is going to fall out when we put a 0 in, and we just divide by 4, and our y-intercept is 3. We're going to go on the graph. We're going to put a point on the x-axis at -4, and we're going to put a point on the y-axis of 3. Connect them. We've got our line. Now let me ask you a question. Play teacher here. What do you think a mistake might be? Number 1 is to switch them. So again, remember what our 2 intercepts were, right? So you're going to take and go to the x-axis at -4 and put a point. You're going to go to the y-axis, put a point at 3, connect them with a straight line and arrows, and there is your equation. -3x plus 4y equals 12. There is your line. Pretty easy to graph. Okay, so let's just talk about the weirdos. And I've talked about these in a previous video. But basically, what happens if you have y equals 4? That means that every point on this line has a y coordinate of 4. So 2, 4, 6, 4, -3, 4. Think about that. So 2, 4, and 3, 4, and -6, 4. And pretty quickly you can see that it's going to be a horizontal line through the point or the y-intercept 4. Now when we go down to x equals -2, every point on this line has an x coordinate of -2. So think -2, 3, -2, 4, -2, -4, -2, 10. And pretty quickly you see that this is going to be a vertical line going through x equals -2. So look at this line, this blue line, and every point on that line has an x of -2. And look at this red line. Every point on that line has a y coordinate of 4. So when you see y equals a number, it is a horizontal line through that y-intercept. And when you see x equals a number, it is a vertical line through that x-intercept. Pretty cool. Oh, by the way, you probably already figured that out if you did the zogs. Okay, so the next question is, how do we write equations that were in slope-intercept form? How can we write those in standard form? So remember, to be in standard form, the x and y term have to be on the same side. So right now, I need to subtract 2x from both sides. And when I subtract 2x from both sides, it will disappear from the right. So it will no longer be over here, and I will subtract it from the other side. Now, when I write it, I'm going to put the x term first. So there's the -2x. There's the y that was already there, and we left the constant. So we subtracted 2x. The number one mistake is just to put it over there as a positive. Remember, opposite sides, opposite operations. So now the next thing is, what if we've got kind of a mess like this? We have two problems over here. The first one is that, again, the x term needs to go to the other side. But the other problem is that, remember that the a, the b, and the c have to be integers, not fractions. So remember clearing fractions a long time ago in Unit 2? Remember multiplying by the common denominator? So we're going to start by getting rid of these fractions because they cannot be in standard form, and we're going to multiply everybody by that 3. We're going to multiply the y by the 3. We're going to multiply the 1/3 by 3, x, and we're going to multiply the 4/3 by 3. And when we do that, we will lose all the fractions. So 3 times y is 3y. 3 times 1/3 is 1x. And 3 times the 4/3 would be, the 3's would cancel, would be the -4. We got rid of the fractions, so we're halfway to standard form. Now remember what we did over here. This x needs to come back over here. So we're going to subtract x from both sides. When we subtract x, we're going to put not x on the other side, but -x. Now, I just want to mention something here. I am perfectly fine that you leave it this way, but if you were to go out and kind of Google standard form, they would talk about that you're not allowed to have the coefficient of x be a negative. So if you multiply every term by a -1, this one by -1, this one by -1, and this one by -1, you could write it this way. These are the same equation, and some schools of thought are that you have to have it looking like the second one to be in standard form. Now listen to what I'm about to say. I accept it either way. We're still learning. Okay, so now what I'd like you to do is pause the video, well, it'll stop for you, and make this one be in standard form with integer coefficients. Okay, so this one's pretty easy. This just needs to go on the other side. So you would just have to add the 5x. Oops, I forgot we had to find the intercepts too. Now to find the intercepts, basically what you're going to do is we're going to cover over, if we want the x-intercept, we're basically going to cover over that and now solve this one-step equation. Divide both sides by 5, and you get 26 over 5, and that's going to be your x-intercept. To find the y-intercept, I'm going to cover over this term, and boom, we're already there. It's 26. Okay, so now what I'd like you to do is you're going to do this one, 2 jobs, write it in standard form, no fractions allowed, and find the x and y intercept. Okay, so first of all, did you clear the fractions by multiplying everybody by 2? 2 times the y, 2 times the 1/2 x, and 2 times the 1. And now it kind of looks like what we're doing over here. you need to subtract x from both sides, and he's going to be the leader, so that's why he's out in front, negative x plus 2y. This is your standard form. Now, how do you find the x-intercept? Well, I'm going to do what I did a second ago. I'm just going to put a little box out here, and for the x-intercept, I'm going to cover over the y term, because 2 times 0 is 0. And now solve this one-step equation. I need to divide both sides by negative 1, and my x-intercept is going to be negative 2. Now to find the y-intercept, I'm going to cover over that, solve that equation, divide by 2, and I have 1. That's how easy it is to get the intercepts. For the x-intercept, you let y equal 0 in standard form. And for the y-intercept, you let x equal 0, and there they are. So what I'm going to just do is going to remind you, just graphing a line, just to finish off here. So remember that we wrote this equation in standard form. We found the x-intercept, and we found the y-intercept. Now the y-intercept's the easier one here. I had to change my scale to make it work, so, right about there. Now this, here's a case where we can't leave it as improper. So 5 goes into 26 5 times. So it's like 5 1/5. So a little past the 5, right? Just barely past the 5. And then I pick up my ruler, connect the 2 points, and there is my line. Don't forget to put your arrows on your line. It's not a segment, it's a line. Okay, let's do the same thing with number 2. We're going to multiply, remember, everybody by 2. We found the x-intercept. We found the y-intercept on the last page. The x-intercept, we're going to put, my point's got a little weird box there, so you know what? We're going to put the x-intercept right at negative 2. We're going to put the y-intercept at 1, connect them with a line, and that's how we graph using standard form. So we have talked about switching slope-intercept to standard form. We've talked about standard form and finding the x and y-intercepts and using those to graph. So we have one last thing to do today. Where the heck does this get used in the real world? So here's an example of an application that uses the standard form. So imagine that you're going to go out sort of jogging and running. So you're going to kind of do interval training. Sometimes you're going to be jogging, sometimes you're going to be running. Now, when you jog, you burn 7.3 calories per minute. And when you run, you burn more, 11.3 calories per minute. We are going to write an equation to find the amount of time jogging and time running to burn 500 calories. The first thing we need to do is read that question and see what our 2 unknowns are. What are they? Well, basically, it's time jogging. So I'm going to let x be the minutes jogging, and I'm going to let y be the minutes running. And oh, by the way, if you switch those and sort of put y as the minutes jogging and x as the minutes running, there's really not a dependency here, so you would be equally as right. Now we're going to write an equation. So what goes with the jogging, what goes with the running, and what's your total? See if you can write that equation yourself. If not, come back, we'll do it together. So jogging goes with the 7.3 calories. So if you were to jog only 1 minute, you would burn 7.3 times 1 minute jogging, which would be 7.3 calories. If you jogged 2 minutes, it would be 7.3 times 2, and so forth. So now, how about running? Well, running is going to go with 11.3. And basically what we've got here is this is your calories jogging, and this is your calories running. And if you add your jogging and your running calories, you want it to be 500. So now we have to find the x and y intercepts. And here is where you really want to pick up your calculator. So remember, to find the x-intercept, we're going to let y equal 0. So this is the equation we're going to solve. To solve this one-step equation, divide 500 by 7.3, and that will be your x-intercept. And then do the same thing by letting x equal 0 and solve this one-step equation, and you'll get the y-intercept. Let's see how we do that. Go ahead, give it a try. So the x-intercept should be about 68.5 minutes. It's 500 divided by 7.3. And the y-intercept should be about 44.2 minutes running. So my question is, can you graph this? So on a piece of regular graph paper, let's set this up, put your x and y intercepts in that we just found, connect those, and you'll have the graph of the running and jogging for 500 calories. So let's see how you did. Remember where our x and our y intercepts? Let me just go back and remind you of those. So remember that the y is about 44 and the x is about 68. And so I just go to those axes and I put the dots and I connect them. And that is my graph of running versus jogging. So what does this mean? Oh, by the way, no arrows, guys, because you're not going to go into negative minutes running or negative minutes jogging. So if you were to pick any point on this line, that would be a combination of minutes jogging and minutes running that would burn 500 calories. So I'm just going to go over here and I'm just going to grab a dot here with mine. And I'm going to come over and I'm just going to stick a point, like, let me pick a different color so it doesn't look like mine. Like, boom, right there. That's about, looks like 22 minutes jogging and just over 30 minutes running, you'd burn 500 calories. This one right here, boom. If you jog like 58-ish minutes, you're going to have to run about 9 minutes or 8 minutes to get the 500 calories. So every single point on here would be a solution to that equation. Not points out here and not points in here, but anybody on the line is a combination of minutes jogging and minutes running that will add up to 500 calories. So today we talked about standard form. We're going to remember that standard form is ax plus by equals c. We learned how to find the x and y intercepts from standard form pretty easily and to graph those very easily to graph the line. We then talked about how do we switch slope-intercept form to standard form, and then we gave an application here of how to apply this to the real world. So we're just going to start practicing standard form, and I'm just going to let you know that there will be a third form of line coming up pretty soon. So that's standard form. Have a great day.